guys, welcome back to my YouTube channel. Let's crack real math. My name is Viraaj, and in this video we're going to have a look at geometric progressions. So before I begin the video, please do not forget to perform an LSS, that is like, share and subscribe. And without further ado, let us begin. So in my previous video I took a look at arithmetic progressions, and this time around we're going to have a look at geometric progression. Now, what is a geometric progression? A geometric progression is nothing but a series of numbers in which each term before the next term is multiplied by a constant value. So for example, let's say I have 6 as my first term, and then my next term is 3. Alright, and then my next term is 1.5. If you see within these three numbers, you can see that each time I'm timesing my term by half, times a half, because 6 times half would give you 3, and then 3 times half would give you 1.5. Likewise, 1.5 times half would give you 0.75. So unlike in arithmetic progression, you're always minusing or adding a constant value. In geometric progression, you're multiplying by a constant value. Now of course this could go the other way around as well. It could be 6 to then 12 to then 24, in this case we're timesing it by 2. It could also be something like 6 to minus 3 to 1.5 to then minus 0.75 if we consider timesing it by minus 1 over 2 each time. So that's how the geometric progression works. Now, in geometric progressions there are a few formulas to note, so let's get into it. The first formula that is worthy of considering is the nth term formula. So the nth term is equal to AR with r raised to power n minus 1, where A is your first term, your r is the common ratio. The common ratio is simply the number that you're timesing by. So in this example here, minus 1 over 2 is the common ratio. In this example here, it's 2, that's the common ratio, because I times 6 by 2 to give me 12. I times 12 by 2 to give me 24. So r is the common ratio, and n is the term that you're looking for. So let's say I want to know the 10th term. What's the value of the 10th term of that progression? So I will substitute my 10 into n over here and subtract 1. So then I would have AR to the power of n minus 1. Regarding if my n was 10, then it would be AR to the power of 9. Now, how to get your r? A lot of the times the r will be given to you, but sometimes you'll have to figure it out. One easy way to figure out your r is you can say that your common ratio, is equal to your second term divided by your first term. Or you could also say your third term divided by your second term, or you can say your fourth term divided by your third term. You can even say the common ratio can be your 73rd term divided by your 72nd term, as long as what you're dividing are between two values of those geometric progression close by. So what I'm saying is, let's look at this example here. I had 6, 12, 24, and let's say 48. If I want to find the common ratio, I could simply do my second term divided by first term. That's 12 divided by 6, and that would give me 2. I could do my third term divided by my second term. That's 24 divided by 12. That would still give me 2. So that means it's correct, because your common ratio is meant to be the same throughout. However, I cannot say my fourth term divided by my second term, because that would give me 4. And that's not my common ratio. So you can't, jump. If you're dividing it, if you're trying to find a common ratio by this method, you need to make sure that the terms that you're dividing each other by are very close, like close to each other. Another way of expressing a geometric progression can be in this way. So let's say we have a, that's our first term. Our next term would then be AR. Our term after that would be AR squared. Our fourth term after that would be AR cube. So our first term is A, second term is AR, third term is AR squared, fourth term is AR cube. So sometimes you may not know your first term or your common ratio, but they can tell you that a particular term, let's say the third term is 44, just for an example. So they say your third term is 44, so you look at your third term, that's AR squared, and it's equal to 44. And perhaps they gave you either one of the first term or the common ratio. Let's say they gave you the first term to be 4. So you now have 4r squared equals to 44. And then you can simply, very easily find your r squared by a simple algebra. So this would be r squared equals to 11, and your r would be plus minus root of 11. That's another way of how you can find out either your a or your r. On to the next formula that we need to know, and that's the sum of n terms. Sum of n terms. Now we have two formulas for these. The first one is a, that's your first term, into r to the power of n minus 1 bracket all over r minus 1. And this formula is applicable when you know your r, obviously, and in the case where r is greater than 1. So when your r is greater than 1, let's say 2 or 1.5, even 1.1, that's when you use this formula. Or the other formula is a into 1 minus r to the power of n all over 1 minus r. In this case where your r is less than 1, so 0, 0 0.5, minus 1.5, minus 3, that's when you use this formula. So they look pretty much the same, except that just these two over here are just reversed in order over there. And the final key formula to take note of is the sum to infinity formula. So sum to infinity formula, that's equal to a over 1 minus r. A is your first term, r is your common ratio, and this is applicable when r is greater than minus 1 but less than 1. Sorry, yeah, when r is greater than minus 1 but less than 1. That's when the sum to infinity formula can be applied into a certain question. Now that we have our basic knowledge grounded, let's look at our first example. Okay, the first example. It says the first term of a geometric progression is 12 and the second term is minus 6. Okay, good to know. It says find, for the I part, the 10th term of the progression. So based on the information we have, first things first, it says the first term, that's our a, is 12. And it said the second term is minus 6. So we can say that AR is equal to minus 6. Now, if you look at it, all you have to do is substitute this a is equal to 12 into the a over here. You now have 12r equals to minus 6. And your r is just minus 6 over 1 over minus 6 over 12, which is the same as minus 1 over 2. That's one way of finding your r. The other way you could have found your r is you could have simply said, okay, our first term is 12 and our next term, second term, is minus 6. So let me just do minus 6 divided by 12, and this will still give you minus 1 over 2. So whichever way you want to find your r, do the one that's most comfortable for you. But that's not the question. The question is find the 10th term of the progression. From our nth term formula, which is nth term is equal to AR to the power, with r to the power of n minus 1. We know our a, we know our r, we know our n. In this case our n is 10 because it's asking us for the 10th term. Substituting these values, we have nth term to be equal to 12 into minus 1 over 2, which is our r, to the power of 10 minus 1, which is 9. And plugging this into your calculator, you should get minus 3 all over 1, 2, 8. And that is your 10th term of this particular geometric progression. The next part says, find the sum to infinity. So using our formula, sum to infinity formula, that's sum to infinity, that is a all over 1 minus r. We know our a, that's 12 all over 1 minus 1 over 2. Because the formula is 1 minus r and our r is minus as well, it would be 1 minus r, which is 1 minus 1 over 2. And be careful, because if you have two negatives, they eventually cancel out and become a positive, so this will become 3 over 2. Negative is the most dangerous sign in mathematics. And completing this, 12 over 3 over 2 should give you 8. So the sum to infinity of this progression is simply 8. On to the next example. Okay, this one says the third term of a geometric progression is minus 108 and the sixth term is 32. Okay, good to know. It says find the common ratio. Right, so we know our third term, the third term of geometric progression is minus 108. So we can say we have AR squared equals to minus 108. And our sixth term is 32. So we can say AR to the power of 5 is equal to 32. Now, when you have this type of a scenario where you have two different type of equations, you must be thinking that, okay, let's say a the subject of the formula here, then substitute a back into this equation and solve it simultaneously. Yes, you are correct, but it is very time consuming, and in exam situations time is of essence. So another quicker way of doing this is simply divide a squared by ar to the power of 5. Sorry, divide ar squared by ar5, ar to the power of 5, and divide minus 108 by 32. So create another equation such as like this: ar squared over ar to the power of 5 equals minus 108 all over 32. And the essence of doing this is to simply cancel out the a, because a and a will cancel out. R squared divided by r to the power of 5 would give you r to the power of minus 3 using your law of indices. If you're not comfortable with that topic, you can watch my previous video on laws of indices. So r to the power of minus 3 would give you minus 108 divided by 32, which, if I'm not wrong, should be minus 27 over 8. Let me just check. Yep, it is. So it's minus 27 over 8. And you can use a calculator to directly find the value of r. R would be the minus third root of minus 27 over 8. And using your calculator, you can find out that r is minus 2 over 3. So our common ratio is minus 2 over 3. The next part says says find the first term. So we know that our first term is a, so we've made an equation over here. AR squared equals to minus 108. So AR squared equals to minus 108. We know our r now to be minus 2 over 3. So substituting that r here, we have a into minus 2 over 3 squared equals to minus 108. Solving for r, you divide, solving for a, sorry, you divide minus 108 by the square of minus 2 over 3, which is 4 over 9, and a would be, doing that in your calculator obviously, a would be minus 243. So that is our first term. Likewise, you could have substituted this r value in the second equation over here. It would give you the same thing. And the last part of the question says find the sum to infinity. So using our sum to infinity formula, which is equal to a over 1 minus r, we know our a, we know our r, and just plug in the values. This should be equal to minus 2, 4, 3 all over 1 minus 2 over 3, because our common ratio is minus 2 over 3, so 1 minus 2 over 3. And doing this in your calculator, you should get a value of minus 729 over 5, and that is the answer for the sum of infinity of that question. And on to the final example, and this is a challenge question. So please do pause the video and have a go at this by yourself, and then resume the video to see if you're correct or incorrect. If you are incorrect, please take note of your mistake. So this question says a geometric progression has first term a, common ratio r, and sum to infinity 6. Okay, now it says a second geometric progression has first term 2a, common ratio r squared, and sum to infinity 7. Find the values of a and r. Now it may look complicated at first, but let's bisect this question. From the information we have, it says a geometric progression has first term a. So okay, we have a, that's the first term. It says the common ratio it has is r. So we have r as a common ratio, and the sum to infinity is 6. So the sum to infinity is 6. Now it says a second geometric progression has first term 2a. So that has a first term of 2a, the common ratio of r squared, and the sum of infinity of 7. So sum of infinity of 7. Now these are two separate progressions with the separate parameters they both have. But if I am looking at both of them, the only equation I can think that can connect each of these parameters, so these parameters within themselves and these parameters within themselves, the only equation that can connect them is the sum to infinity equation. So looking at this first one, we would have sum to infinity equals to a all over 1 minus r, and because they told us that the sum to infinity is 6, all we can do is we can just simply write 6 equals to a over 1 minus r, and if we cross multiply, we would have 6 minus 6r equals to a, and we can call this our equation 1. So this is one equation that we have derived. Now with the parameters of these, we can say s, the infinity of this term, is equal to a over 1 minus r. Our sum to infinity is 7, so 7 equals to 2a, because it said the first term is 2a, all over 1 minus r squared, because it said the common ratio is r squared. And again, cross multiplying, we would have 7 minus 7r squared equals to 2a. You can bring the 2a over here, you can have 2a minus 7r squared plus 7 equal 0, and we can say this is our equation 2. So we have a quadratic equation in one, and we have a normal linear equation in the other one. And as I can see, I can simply substitute my value of a all the way here and solve for r first. And this is basically me solving a simultaneous equation. So if you're not comfortable solving simultaneous equations, you can watch my previous video on solving simultaneous equation using both substitution and elimination method. So substituting my a over here, I would have 2 into 6 minus 6r minus 7r squared plus 7 equals 0. 2 into 6 gives me 12. 2 into minus 6r gives me minus 12r minus 7r squared plus 7 equals 0. Now I can collect my like terms. I would have minus 7r squared minus 12r, and 12 plus 7 would give me okay, just a second, sorry guys, this will be minus 2a. So sorry, minus 2 into 6, that's minus 12. Yeah, and then minus 2 into minus 6r would be plus 12r. Yeah, sorry, minus 7r squared plus 7. So minus 7r squared plus 12r, and then minus 12 plus 7, that would be minus 5 equals to 0. And I can say I'll take all this to the other side, so I can have a positive r squared coefficient. So I would have 7r squared minus 12r plus 5 equals 0. So now all I can do is solve this quadratic equation by factorization method. So I can say 7r squared minus 5r minus 7r plus 5 equals 0. This can be factorized by r, so r into 7r minus 5, and this can be factorized by minus 1, I think. Yeah, minus 1 into 7r minus 5 equals 0. I have r minus 1 and 7r minus 5. I have my r to be 1, or my r to be 5 over 7. If you're not comfortable solving quadratic equations, you can watch my previous video on solving quadratic equations. So I have two values of r is equal to 1 and r is equal to 5 or 7. Now the question arises, which one should I use? Which one should we use? It said when you have a geometric progression, it's very unlikely that your r value would be 1, because think of it, your r value can never be 1, because if you have a term, let's say 6, you start with 6, that means you're telling me that every time you're just timesing it by 1. So times 6 by 1, you get 6, times by 1 again, you get 6 again, times by 1 again, and you get 6 again. So that's why in this case, because it said a geometric progression and not a constant term being used in the progression, we can say, it's safe to say that our r is 5 over 7 and not 1. So we use our value of r as 5 over 7 to now find our a, because the question, remember, said find the values of a and r. We found the value of r, now we need the value of a. And to get the value of a, we can simply substitute our value of r of 5 over 7 over here to simply solve for a. So we now have a equals to 6 minus 6 into 5 over 7. Your a would now be 6 minus 30 over 7, if I'm not wrong. Yep. And a should be 60 minus 30 over 7. Okay, it should be 12 over 7. Let me just confirm that on the calculator real quick. 60 minus 30 over 7. Yep, 12 over 7. So the first term is 12 over 7, and the common ratio of this question was 5 over 7, and that's the answer to that challenge question. And that indeed brings us to the end of this video. Thank you for watching, guys. Hopefully you liked it. Please do not forget to perform an LSS, that is like, share and subscribe. Also, please feel free to comment any feedback or any questions in the comment sections below. Thank you for watching, guys. Have a nice one.